Our objective is to review translations. The test is the test, questions are the questions. The reality is, if you could do the homework, the quiz is going to be easy. So the reference in the online book, if you want to read the lesson there, and then you can also look at the videos that they have, plus do the personal math trainer, which in this book, the personal math trainer really teaches you how to do the problems. Kia, I need you focused. So this is lesson 9-1 in the book, and the pages go from 281 and ends at 286. So not all of that is lesson, some of that is the practice problems, but you might want to practice those as well. And then you have the answers online as well to the odds, okay? So keyword, what's the keyword that we put with translation? What's a word that describes the translation? And they mentioned it in both the videos too. So if you remember, that's a slide. So sliding something isn't turning it around, it's just sliding it to a new position. So that's the word that we associate with this. And with a translation, it could be a horizontal slide. And that is affecting the x's. That's horizontal is your x axis, okay? And you can either go slide right, so you can have a movement right, which are the positive x's, or you could go left, which would be a negative x, okay? You can also do a vertical slide, which is dealing with your y's, and you can either go up if you have a positive y, or you can go down if you have a negative y. And then you can also do a combination. And a combination slide is going to have an x and y change. Okay, but again, you're just sliding to a new location. Sorry. The original figure is called the pre-image. And when we write the vertices, we just write them normal letters, and because they're points, we always use capital letters. Aaron, you gotta write down. We use capital letters whenever we're describing points. Anthony, you gotta write. The new location, now it's called an image. And we have to add the prime symbols to each of the vertices, because it's not, if I wrote A, B, C, then they should be in the exact same position they were originally. So when I write A prime, B prime, C prime, it's telling me it's the same vertices, but now they're in their new position, okay? So those terms of pre-image and image, very important to understand. So with a translation, the pre-image to the image, the shape remains the same, the size remains the same, the orientation, so it doesn't rotate, stays the same. And we had talked about in class, I think on Monday, there is a word that describes when two figures are identical, what do we use to describe them? Justin? They're congruent. So the image and pre-image are congruent in every way imaginable. And that's, again, the second video that I sent you guys from Virtual Nerd with the new nerd. It talked about that more so, okay? The last is to describe the rule, because you need to have a rule to tell you what to do. So the rule is basically the directions. Oops, sorry. From the pre-image to the image. And they presented the rule two ways depending upon how the problem was given to you. If they gave you a graph of the pre-image, they provided the rule more in words. And they would provide the rule like this. Right 2 and down 3. And what they were telling you is, because on the right of a number line is positive, is that they said you go on the x-axis, positive or positive 2 on the x-axis. And then from there, you would go down 3 on the y-axis. And then you would mark your new location. So you could do it without having to really think about it. You just follow the directions. I'm going to move 2 on the right and go down 3, okay? And then if they didn't give you a diagram and all they did was give you points, they gave you notation. So this is what translation notation, and this showed up in your homework several places. It has 2 components to it. It's comparing to the original. So here's your pre-image. So basically it's saying for each vertex of your pre-image, and we'll just represent the vertexes x and y, what I want you to do is to move right 2, so add 2 to your x-axis, and I want you to move down 3, so you're going to use a negative value on the y-axis. And these 2 notations, the one in right 2 and down 3, and the arrow notation that you see here, mean exactly the same thing. But what's nice about the second one, I don't need to draw a picture, I don't need graph paper. So an example that would go with this one would be, let's say we have point A is at 1, 2, point B is at 3, 5, and point C is at -2, -1. If I want to know where A prime, B prime, C prime is, I'm going to apply the rule. So for A prime, I'm going to take my numbers and I'm going to apply the rule. And the rule says, let's add 2 to the x and let's subtract 3 from the y. The result is going to be where A prime will be located. So I'm going to do that for each of these. For B prime, I'm going to take my original coordinates, which were the 3 and the 5. But on the x, I'm going to add 2, and on the y, I'm going to subtract 3. On the C prime, my original coordinates were -2 and -1, and the rule tells me to add 2 to the x and subtract 3 from the y. So where I end up with, A prime is at 1 plus 2 is 3, 2 take away 3 is -1. B prime, 3 plus 2 is 5, 5 take away 3 is 2. C prime, -2 plus 2 is 0, -1 take away 3 is -4. So I don't need to draw the picture of it. I can simply just apply the rule mathematically and come up with it. And what I was doing as I was going through the homework is that I would do the rule, then I would draw it, and I would check to see if my rule and my drawing were the same. And so that helped me do that. But again, you're not always going to be provided graph paper, so the rule you can do just mathematically. Okay?